Hello, dear students. I am Aditya Gupta, and a very warm welcome to this lecture on the chapter of lines and angles. Right now, in CBSE board exams, the weightage of this particular chapter is around 4 marks. But this is the most important. I would say not the most important, but the most fundamental chapter that we have to learn. The reason is that at the end, after we are able to complete this chapter, one very important conclusion that we have to take away is a technique called angle chasing. So angle chasing is so fundamental to whole of geometry that without that we cannot do anything. If we don't know angle chasing, we cannot study geometry. That's it. We cannot study geometry if we don't know the technique of angle chasing. So angle chasing technique would be learned in this chapter itself, which would be used in any and every chapter of geometry that we'll be doing further, right? So that's why this is quite an important chapter from a fundamental perspective, maybe not from Mark's perspective, but unless we are very thorough with this chapter, our other further geometry chapters would be greatly affected. And if we have a good command over this chapter, those chapters will also become a lot more easier in comparison, right? So let's get started with this chapter. First of all, what are lines, what are angles, and where do we actually encounter them in real lives? So many real life examples can be thought of. One example that we can think of in physics, if we talk about, is, let's say sometimes you might have in your physics activities, you might have heard about a periscope, and even might have made one as an activity. So what happens in a periscope is that there is a mirror at a perfectly 45-degree angle. Here is another mirror at a perfectly 45-degree angle, and this perfect 45-degree angle is needed because we know that light follows the property of reflection. So if a light will come like this, then this parallel to this periscope, then since this is the perfect 45 degree, this will also be 45 degree, and due to the properties of reflection, it will go perfectly straight. Since this also should be 45 degree, then since this is 45 degree, this will also be a perfect straight. The line will leave the periscope perfectly straight, and that's what we want. Because if here is an object, any object, then its light should reach our eye perfectly, whatever we are looking into it. So we don't want a blurred image, we want a crystal clear image. So to ensure that, the angles of these mirrors and the angles between these sides, these legs of the periscope are very important. That it is it is very important for us to make sure that these angles are absolutely precise. Only then will we be able to build a very good periscope. Same is the thing in angles related to cameras and telescopes, because in telescopes also, after it literally took so many years to build a design of a telescope which gives the best image, and it was actually devised by Newton. But look how long it took for a person to actually devise such kind of a telescope which gives really focused image. Previous versions of telescopes actually were giving blurred images, but after a lot of thinking, lot of effort, Newton was able to design such a telescope in which the angles matched so perfectly that the image was almost perfectly focused, not blurred like before. So it is very important to understand the significance of angles, because they also play a critical role, especially in the physics related to light, correct? In fact, even in reflection, refraction, almost anything related to light, angles always come into picture. So now that we have seen some application in physics, let us also understand some applications, let's say in architecture. So even a lot of ancient temples that were built around India, even at that time, they had a lot of knowledge about angles. Because if, let us say, this is a floor of a building, right? Then the wall that we wish to build, Obviously we would like it to be perfectly upright. It should not lean towards this side or that side, otherwise in a few years it will easily fall and the building would collapse. So it is so in architecture it is of utmost importance to make sure that the walls of the buildings are absolutely upright. Not even 1 degree of leaning should be there, because over the years that 1 degree exponentially increases and makes the building fall. Not exponentially, but what I'm trying to say is that even a small tilt, even 1 or 2 degree tilt over the years builds up, gradually builds up and becomes more and more and more, and it actually leads the building to collapse. So the perfection needed, the amount of perfection needed in ensuring the wall to be upright actually takes skill and effort, right? So even there was some instrument even in ancient India whose name even I don't remember, but anyway, there was an instrument which was used to make sure that the buildings are absolutely upright at a perfectly 90-degree angle, okay, with the floor. Otherwise, if it is tilted even a little bit here, let's say this is a building, even if it is tilted little bit here, then over the years it can fall, right? It can crumble down. So even in architecture, it is very important. Apart from that, even in carpentry, it is used a lot. Angles are very important, especially in high precision carpentry, quality carpentry, especially seen by skilled carpenters in Japan, especially. Those their angles become very important. Okay, so that's how you become so much skilled in carpentry, when you're able to make sure that the precision in carving out the angles out of the wood is very precise, is very accurate. So once you have achieved that, you can say that you have become a very skilled carpenter, right? So no doubt about that, that a lot of applications are there as far as angles are concerned. In fact, angles can also be used to measure Earth's radius, Earth's entire circumference, okay, moon's size, mass of the moon, because from the earth we are able to measure the angle that the moon subtends on the earth using some equipments, and using that angle we are able to apply mathematics and find out its radius and weight, etc., right? So no doubt angles are very very important almost in any category of science, architecture, or any practical endeavor that we might take. Even here, such a brilliant diagram is given here. The Eiffel Tower. Here, this angle is something. This angle is something. Now, of course, the Eiffel Tower must be perfectly symmetrical, otherwise it will fall. So we can say that a lot of effort went into making sure that even this angle and this angle both are exactly the same. That's why it is such a model to behold, and such a brilliant piece, masterpiece, of architecture. By and that's why many people come to Paris to view this, and it is standing upright, it doesn't fall. So architectural importance of angles is so obvious to understand. Now, what are the topics that we'll be covering in this lecture? Those are some basic terms and definitions, then the type of angles based on value and special angles, intersecting lines and non-intersecting lines, and finally a pair of angles. So here we have types of angles based on value. First of all, let's see based on value. Okay, before we start looking at angles without based on values, first let us understand how to name an angle. Okay, so let us say, first of all, how is an angle made? An angle is made between two rays of line. Okay, two rays basically. Okay, so if this is one ray and another ray is inclined to this particular ray at some opening, at some tilt, at some inclination, at some angle, then that's how we measure the angle between those two rays. Okay, so what we are saying is that if, let's say, if suppose this is a ray. Okay, now, okay, let me make a better diagram here. What we are saying here is that if there is a ray that looks something like this, then if there is another ray with the same starting point but with some tilt or some inclination, then that's how an angle is generated between these two rays, correct? So if this is the angle B, if this point, let's say we call A, this point we want to call C, and if we want to refer to this angle, then there are many ways to refer to this angle. One of the ways is to name this angle as angle ABC, because angle from point A, if you go to B and then from B you go to C, then you get this angle only. So we can name this angle as angle ABC. You can also call this or name this angle as angle CBA, because of course if you go from C to B then B to A, then also you are obtaining the same angle, correct? Another way to name this angle can be angle B. Okay, this is also the way in which we can refer to this angle. Okay, so but sometimes there might be a confusion whether it is this angle ABC or this angle. So that we will see once we actually come on to the topic of reflex angle. But right now the basics should be clear in our mind. Whenever we are referring to angle ABC, okay, so I will tell you this in reflex angle, how to make sense of whether it is a reflex angle or a normal angle. So, but basics, I hope you have understood where we are talking about how to name an angle, right? Now, what is an acute angle? An acute angle is an angle which lies between 0 degree and 90 degree, or in other words, an acute angle is one which is less than 90 degree, right? One important thing to understand here is that what are first of all 90 degree, 180 degree, 360 degree, etc. What are these? So what we say is that if there is a straight line, okay, and if there is a straight line like this, now what we are doing is that this complete revolution is divided into 360 equal parts. Let me give you an example what I mean. Let's say if I give you something like this and I ask you to divide it into four equal parts. So the way you can do it is something like this: one, two, three, four. Okay. So all of these angles, these portions are perfectly equal. So here I have divided this given thing into four equal parts. So here this complete revolution is divided into 360 equal parts. So, and each part is called 1 degree. Okay. So that's how we are defining a degree measure of an angle. Okay. So naturally, how much will be this half revolution? It will obviously be half of 360 degree, which is 180 degree, and that's how we get 180 degree as a straight angle. And that's how we can say, once again, if I divide it into two halves, if I divide 180 degree into two halves, we get 90 degree and 90 degree, which we refer to as the right angle. So that's how we are getting a uh, that's how we are obtaining 180 degree, 90 degree, etc. But at the end of the day, we need to understand that an angle, that a degree is just a method to measure the angle. Okay, it is not absolute. Angle can be measured in other units also. For example, one full rotation is 360 degree, half rotation means 180 degree, one fourth of a rotation is 90 degree. So we can also say one fourth of a rotation is a right angle. That's absolutely correct. Okay, so now let's see what we have as an acute angle. An acute angle is an angle which lies between 0 degree to 90 degree. Okay. So here we also have a figure that we are given here, which is less than 90 degree. The reason is that what will be a 90 degree angle? We have already seen that it is one fourth of a revolution. So basically a 90 degree would be something like this, one fourth of a revolution, right? So what is an acute angle? Some angle which is lesser than 90 degree. Okay, the opening or the inclination of the two rays is less than 90 degree, then it will be called an acute angle, right? Now what about an obtuse angle? Obtuse angle is the opposite of an acute angle. Why? Because it is the angle which is greater than 90 degrees but it is less than 180 degrees. Okay, so before that, let us actually discuss right angle first. A right angle is always equal to 90 degree. Any angle less than 90 degree is an acute angle, whereas any angle greater than 90 degree but less than 180 degree is an obtuse angle. So look, what we are saying is that that an angle of 90 degree which is often represented by this symbol. Look, any random angle is represented like this by a curved line, but a 90-degree angle is always represented by a square like this. Okay, so this automatically means right angle or a 90-degree angle. Okay, now what about an obtuse angle? If you increase the angle further more than 90-degree, then what do you get? You get an obtuse angle which is greater than 90-degree, but it must be less than 180-degree. Okay, you can increase the tilt after 90-degree, but don't go beyond 180-degree. Okay, then it will be an obtuse angle. Fine. So for example, 150-degree, 120-degree, 138-degree, all are obtuse angles. Correct. Now what about a straight angle? A straight angle is 180-degree angle, 180 degrees. Okay, so basically if there is a ray that looks like this, then to make 180-degree, just make another ray exactly in continuation with this ray. Okay, so let us say this is one ray. Then if you want to make another, if you want to make a 90-degree angle, a 180-degree angle, then we just have to connect another ray exactly in the same straight line in which this ray is present. Okay, so that's what we are doing. That's why it is called a straight angle, exact 180-degree. This can also be described as half of a complete revolution, right? So if this is the point, then this is a 180-degree angle, which is also called a straight angle because it lies on a straight line. That's why it is called a straight angle, right? Now, what about a reflex angle? Any angle which has a measure which is greater than 180-degree but less than 360-degree. Okay, 360-degree obviously will again coincide with 0-degree only. So is a reflex angle. So basically what we are saying is that any angle which is greater than 180-degree but less than 360-degree is a reflex angle. So the tilt between the two rays is increased even further after 180-degree. Okay, and finally we have a full rotation that we were talking about, an angle of 360 degrees. Complete revolution basically describes a 360 degrees. So basically if I what we can say is that if we have a ray which looks something like this, and another ray starts moving from this ray like this, like this, like this, it starts rotating, then it will reach an acute angle, then it rotates even more further, 90-degree angle, even more further obtuse angle, even more further straight angle, even more it becomes a reflex angle, more and more, more and more, and finally coincides back again with the original. Then this complete rotation, complete revolution that it has done describes a 360-degree angle rotation. Okay, that is what we mean by a full rotation. Now, what about naming the angles? How do, if let's say there are 3 points A, B, C, okay. So if we want to refer to this angle, let's call this theta, then theta will be simply written as angle ABC. But what about if we have to refer to this angle alpha? How will we refer to this angle as? How will we name this angle? So it will simply be named as reflex angle ABC. Okay, angle ABC. The reason it is still angle ABC because of course from A you go to B, you go to B, then you go to C, then only this angle will be created, right? But we put a reflex so as to explain the other person that the reflex angle has to be measured, not the acute or the obtuse one. Okay, so that's how we can differentiate between the naming. If only this is written, it means this simple angle, and if reflex is written, then the bigger angle. Okay, that has to be referred. So I hope this naming is clear, and of course we can also write it as angle B, angle CBA. Here we can also write, you just put the word reflex, reflex angle ABC, reflex angle B, reflex angle CBA, it would mean this angle, correct? Now let us see some special angles. So certain angles are basically given special names based on their relative positions. So mainly they are 30 degrees, 45 degrees, 60 degrees. These are referred to as the special angles. When later we will study trigonometry, we will find that we can easily obtain the values of trigonometric ratios for these special angles. Okay. So this is something that we should be aware of. Now let's see some questions. Classify the following angles into acute, obtuse, right, reflex, angles. Okay, so clearly we can see that this angle lies between 0 to 90 degree. Okay, so since this is less than 90 degree, it is going to be an acute angle. This is 185 degree, which is clearly greater than 180 degree, but less than 360 degrees. So this will be an obtuse angle. What about this? Obviously, this is a 90-degree right angle. So 90-degree angle means it is the right angle. 92 is greater than 90 degree, but it is lesser than 180 degree. So it is obviously going to be an obtuse angle. Here we have done a slight mistake. This will not be an obtuse angle. This will be a reflex angle. Reflex, this is a right angle. Okay. So let us write completely only. Why is this reflex? Because it is by definition an angle which is more than 180 degree, less than 360 degree will be a reflex angle. So we should be careful that we shouldn't do any mistake. Okay, this is a right angle, this is an obtuse angle, and this is again going to be a reflex angle because this is more than 180 degree but less than 360 degrees. So it is once again a reflex angle. Now let us have a look at the answers. Acute, reflex, right, obtuse, obtuse, reflex. Okay, so that's what we have also done. Fine. So I hope this is clear to everyone. Very basic definitions. Now let us see something about what we mean by intersecting and non-intersecting lines, right? So intersecting lines, two or more lines which share exactly one common point are called intersecting lines. This common point exists on all these lines and is called the point of intersection. So basically what we are saying is that if there are two lines, then this is the point of intersection. We can have more lines like this. If they pass through the same common point, then they all are intersecting lines at this point. Okay, but if we draw lines that look like this, then they all are not intersecting, right? If I make lines like this, they all are not intersecting. Okay, to pairwise they might be intersecting, but all of them don't intersect in one single point. Okay, so when we refer to the word intersecting lines, all the set of lines that we are calling intersecting lines should intersect or should pass through one common point. Okay, now when we are talking about intersecting lines, we must note that intersecting lines meet at one and only one point, no matter at what angle they are. So might be angle is like this, might be angle is like this, might be angle can be anything, but they must intersect at a point, at one single point. Fine. No two straight lines can meet at more than one point. This is a very important fact because in Euclid's postulates and axioms we have studied that a unique line passes through two given points. So so no two straight lines can meet at more than one points. So let us assume to the contrary that okay, maybe they can meet. So both the lines meet at A point also, both of them meet at B point also. So since both of the lines pass through A and B, but from postulates we know only a unique such a unique line only exists. So they both must be coincident lines, and hence they are only one single line, not two straight lines. So this means our initial assumption was wrong, and indeed this point is correct, which is telling us that no two straight lines can meet at more than one point. Okay, so they can only intersect at one point, they cannot intersect at more than one point. Okay, now the lines that meet at more than one point are not straight lines. At least one of them is a curve. So for example, this is a curve, this is a straight line, they are meeting at two different points. Okay, fine. Now let us see what about non-intersecting lines. Two or more lines that do not intersect each other are called non-intersecting lines. Of course, if they are intersecting, they will be called intersecting lines. If they don't intersect, they are called non-intersecting lines. One thing a few points we should note are that they can never meet. Of course, if they are not intersecting, they can never meet, right? They are also known as parallel lines. Yes. For example, in a racing track, these lines are parallel to each other because they will never meet. If a person starts running from here, he can go forever. These lines will never meet. A person running from here also can travel like this in this lane. Another person can travel in this lane. So all these lines that are present, they are parallel lines. Okay. Parallel lines are always at the same distance from one another, as we have already seen in the previous chapter of Introduction to Euclid's Geometry. And distance between the any two parallel lines is always the perpendicular distance that we are talking about. Okay, so if there are, let's say, two parallel lines, then if you choose any point at all, and if we drop a perpendicular from this, then this will automatically be perpendicular due to the fifth postulate of Euclid. And this distance, if this distance is d, and if you take any other point, let's say b, and then drop a perpendicular on this line, then this will also automatically be perpendicular, and this distance will also be d. So no matter what point you take the distance between this point and the line and the other line, the perpendicular distance would be the same, and this distance itself is called the distance between these two lines. Because even if I take a point on this line rather than on this line, if I take on this line also and then also drop a perpendicular, then it will automatically be perpendicular, so this distance will also come out to be d. So since the distance is independent of what point we are taking, no matter if you take on this line or on this line, and wherever you take, still the distance of that point from the line is coming to be a constant d. So that's why it is also referred to as the distance between the two lines themselves. Okay, so that is the point that we are talking about, that parallel lines are equidistant from each other. Now let's see, does the figure below show intersecting lines at different angles? So of course the answer is yes. The reason is all of these lines are obviously passing through this one single common point. So clearly they are intersecting lines at different angles. So for example, the angle might be alpha here, this angle might be beta, okay, this then gamma. Okay, so basically different angles they are meeting. Now, how many lines are there if we want to count, for instance? So one of the lines is this complete line. Okay, let me draw a better diagram. What we are saying here is that this complete line that has been drawn here is line L1, right? Similarly, this complete line, okay, is L2. Similarly, this complete line is L3. Similarly, this complete line is L4. So in total, there are four distinct lines that are intersecting at a one single common point. So that's what we are talking about. As shown here, four different lines, four different intersecting lines. Now, let's also talk about a pair of angles. So complementary angles, first let us have a look. Any two angles whose sum is 90 degree are called complementary angles, and one angle is called the complement of the other. So example here is, we have a very good example shown, 30 degree and 60 degree. Why do they form a pair of complementary angles? Because their sum 30 plus 60 comes out to be 90 degree. Okay, so that's why they are called complementary angles. And if I say what is the complement angle of 30 degree, it would be 60 degree. What is the complement angle of 60 degree? It is 30 degree. Okay, so they are complement of each other. Another example can be, let's say, 20 degree and 70 degree. Their sum is also 90 degree, right? Similarly, 45 comma 45 itself, because both of their sum is once again 90 degree, right? What are supplementary angles? Supplementary angles, any two angles whose sum is 180 degree, which is a straight angle only, are called supplementary angles. One is called the supplement of the other. So here we have an example, for instance, 73 degree. 73 degrees this much, and this angle is 107 degree. So clearly the sum of both these angles comes out to be 180 degree only. That's why they are supplementary angles, a pair of supplementary angles. What is the supplement of 73 degree? 107 degree. What is the supplement of 107 degree? 73 degree. Okay. What about adjacent angles now? Two non-overlapping angles are said to be adjacent angles if they have a common vertex, a common arm, and two other arms lying on opposite side of this common arm, so that the interiors do not overlap. Now let us try to make sense of what this actually means. So, okay, just a second, let's see. Yeah, so we are saying that any two non-overlapping angles are said to be adjacent angles if they have a common vertex. So let's say there is a common vertex, a common arm. Now, what do we mean by an arm of an angle? So if there is an angle, of course, there are two rays associated with it, right? So these are called the arms. Both of these rays are called arms of the angle. So a common arm, okay, let's say this is the common arm, which is the common ray itself, and two other arms lying on opposite side of this common arm. So if if one of the arms of an angle is here, and let's say this angle is alpha, then for the other angle, the arm should lie on the opposite side of this side. So what is the opposite side? This is the common arm. This is one of the sides, okay, of the with respect to this common arm. Then the other side would be here only, correct? So that's what we are saying. So on the opposite side, just let me draw a better figure. On the opposite side, if some arm is lying, these two sides are obviously opposite, right, with respect to the common arm. So that's what it is saying, that they should lie on opposite side of this common arm. And this angle, let's say, is beta, then clearly their interiors do not overlap. Overlap means, let us say this is a 30-degree angle, and let us say there is a 60-degree angle. So the problem is that here they have a common portion of their interiors. So this should not happen. So that's what it is saying, that their in this manner their interiors will not overlap if they are on opposite sides, right? If their arms are on opposite sides. So these alpha and beta, these two angles will be adjacent angles since they have a common arm and the other arms are on opposite sides of this common arm, right? Vertically opposite angles. Two angles formed by two intersecting lines having no common arm. Okay, just a sec. Let's see. Having no common arm are called vertically opposite angles. So let's say there are two intersecting lines. Even in this figure, it is shown very nicely. These are two intersecting lines, okay? And then angles which have no common arm. So for instance, if I talk about this angle, its arms are this arm and this arm, correct? So I cannot take this angle now, because if I take this angle, it also shares this arm with this, but it is saying here no common arm should be here. So I can't take this angle. I also can't take this angle because it also will share this common arm with this angle. So I also can't take this. I can only take this angle because its arms are these, which are obviously not common with the arms of this angle. So that's why these will be vertically opposite angles. So whenever two lines intersect, the pair of angles having no common arm can be called vertically opposite angles. So if this is alpha and this is beta, alpha comma beta form a pair of vertically opposite angles. But let's say if you take one of the angles as this one, then it's, so let me draw this figure once again. If you take this as one of the angles, its arms are these two, correct? So I cannot take this angle because both of them share a common arm, but I can choose this angle because its arms are this and this. These two rays are there. So clearly, 1, 2, 3, and 4 rays, they have nothing in common. So they can also be, they also form a pair of vertically opposite angles. So if this is gamma, this angle is delta, then gamma comma delta also form a pair of vertically opposite angles, correct? Now what about a linear pair? Any two adjacent angles are said to form a linear pair if their sum is 180 degree. So first of all, there must be a pair of adjacent angles, and then their sum should be 180 degree. So obviously here in this diagram, this is the common arm due to which this angle and this angle are clearly adjacent angles, right? Because other arms lie on opposite sides also, right? So it is satisfying the criterion for adjacent angles. Moreover, since they lie on a straight line, alpha plus beta is also going to be 180 degrees. So their sum equal to 180 degrees also satisfied. So these are basically angles that are lying on a straight line. That's also a way in which we can put it. that they are lying on a straight line. So that was pretty much about the basic pair of angles. Now let us solve a question here. Prove that vertically opposite angles are equal. So how do we prove that? First of all, we should know, okay, let us write this here. We know that a linear pair of angles adds up to 180 degree, right? A linear pair of angles adds up to 180 degree, right? So 180 degree. Now, using this, let us try to solve the question. Let us say this is these are two intersecting lines, and let us talk about these two vertical angles. For example, this and this, correct? So let's say this angle is alpha, this angle is beta, and let's call this angle as something like theta, let's say, correct? Now, let's call this line as L, let's call this line as M. Then clearly we can see, clearly theta plus alpha would be equal to 180 degree, since both theta and alpha form a linear pair of angles, right? They are adjacent also. They are adjacent as well as lie on a straight line L. So obviously then their sum of angles would be 180 degree only, since they are forming a linear pair of angles. So alpha plus theta is 180 degree. Similarly, beta plus theta will also be 180 degree, because both beta and theta are adjacent as well as, or we can say and, lie on the straight line M. Lie on the straight line M. Okay. So the sum of these two angles will also be 180 degree, correct? So that's what we have written. Now using these two equations, how can we prove that alpha is equal to beta? Look, from this equation, I can write that alpha would be equal to 180 degree minus theta, correct? I have basically transferred this theta onto that side. So alpha is equal to 180 degree minus theta. Similarly, from this equation, I can write beta is equal to 180 degree minus theta, correct? So we can observe that alpha equal 180 degree minus theta equal to alpha also, 180 degree minus theta equal to beta also. So obviously from the Euclid's axiom, which stated that things which are equal to the same thing are also equal to one another. So using that axiom, we can say that alpha and beta angles will be equal, because both of them are equal to the same thing, 180 degree minus theta, correct? And hence we have concluded that since alpha and beta are obviously a pair of vertically opposite angles, and we have proved alpha equal to beta, so vertically opposite angles will always be equal to each other, right? So now let us see a question here. In this question basically says, in the figure given below, AOC and BOC form a linear pair, and it is also given that x minus y is equal to 60 degree, right? So their difference is given, then find the value of these angles x and y. So one of the equations is already given to us, x minus y equal to 60 degree, but since they also lie on a straight line, and it is given that they form a linear pair basically, so by definition of linear pair, as we have seen, their sum must be 180 degree. So I can say that angle x plus angle y would also be equal to 180 degree, correct? These are two equations, two variables, which we can easily solve. One of the ways to solve these would be, what will be, look, according to the axiom of Euclid, he told us if equals, basically if equals are added to equals, the wholes are equal, correct? if equals are added to equals, the wholes are equal. This axiom we have already seen in Introduction to Euclid's Geometry. So these are two equals, these are two equals. So if equals are added to equals, the wholes, this is obviously the whole, is equal to the wholes. So 60 degree plus 180 degree, the wholes. Okay, so that's what we are saying. Now here, y and minus y will cancel out, and we are left with x plus x, which will give us 2x equal to 180 degree plus 60 degree, which is 240 degree, which will actually give us x is equal to 120 degree. Correct. So this is the value of x. Put this value of x back here in this equation. So what are we getting? 120 degree. From here we are getting this 120 degree plus y equal to 180 degree. I have just substituted the value of x here. Correct. So from here y comes out to be 180 minus 120, which actually gives us finally y equal to 60 degree. Okay, so that's the way we will do it. This is our answer. So I hope this is clear to everyone. Let us now have a look at the solution also. X minus y equal to 60 degree, given x plus y equal to 180 degree, because it is a linear pair. Adding 1 and 2 equations basically means adding equals to each other, then the wholes will also be equal to each other. So similarly, so doing that, we get x equal to 120 degree. Finally, we can substitute x here also. So once again, we'll get the value of y as 60 degree, right? So that's how we get to the answer. One more question. These are some practice questions. You can try to do this. So first question says, which of them is a pair of complementary angles? Hint, what should be the sum? Sum of complementary angles should be how much? It should be 90 degree. You all should be able to recall this, okay? So all you have to do is see which pair of angles adds up to 90 degree. That's it. So you can try this on your own. Let us do this question. Find the missing angle x. Okay, we basically have to find this angle x. I will give a hint here also. What are these two angles? What kind of pair of angles are they? And once you are able to see what pair of angles they form, complementary angle, supplementary angle, linear pair, vertically opposite angles. So that's how we have to find which of these pairs are these two angles forming 20 degree, this 20 degree and this x degree. What pair of angles do they form? And then use the property of those angles. So this is the hint here. Okay. So let me write it also. What pair of angles do 20 degree and x form? Once you know this, the question will become very easy. So I hope you were able to, you enjoyed watching the lecture and learned something new. Thanks a lot for watching. And of course, we'll continue this study of this chapter in the next lecture as well. Once again, thanks a lot.